welcome everybody. Thanks all for coming. Right, just a couple of quick other things whilst we're preparing for Gary's talk. We are exhibiting at the Green Village in Higginson Park on Saturday this week at between 11 and 5. If anybody's in Higginson Park, please visit the Green Village. We'll be delighted to see you. We're also running a photo competition at the moment for pictures that show improvements to the environment. So if you have any snaps that you want to put in for that competition, the prizes are £50, £35 and 2 vouchers for £20 each. So consequently, it is well worth going for. Right, let us introduce Gary. Gary is, I think, the Managing Director of Chiltern Utility Solutions in High Wycombe, and he's a non-domestic EPC assessor, amongst other things. So I'll now hand over to Gary, who will give us his talk. Thank you, Gary.
Thank you for your introduction, John. You don't know what you know of me. I've actually got a master's degree in renewable energy systems. And as you may or may not realize, the most commonly used renewables, wind and solar, you basically got to take them when they're there, and you don't regulate how much is being produced other than by turning it off if you can't use it. So this talk is about how we try to balance supply and demand on the grid. Just 1 second, I think I need to get on the right bit and share screen. Yes. Can everybody see the screen now?
I can see it okay.
Yes, yeah. Me too.
Okay. Well, one of the enabling technologies that allows for an improvement in balancing of the grid between supply and demand is smart meters, because they allow for flexibility of tariffs and can be used at a later stage in conjunction with the Internet of Things, which will allow certain devices don't have to be on at a particular time. They can, their usage can be deferred if necessary. For example, if your washing machine's running, there's no reason why it can't stop for 5 minutes if the grid needs a bit more electricity. So that's the kind of thing we're talking about. But right now, it's really only large users that participate in the flexibility markets in demand side management. People like firms that are smelting metals, or maybe big shopping centres might turn their air conditioning on or off for 10 minutes at a time to help out the grid. It's that kind of situation at the moment, but that's changing. So, by the way, anybody who wants to ask a question, just just ask it during the talk, because it's quite a small group. Who knows what smart meters are and what they're for? Why they're being introduced? Anybody like to say anything? Okay, John.
We've got one, Gary. Eventually, when we do pick a tariff which is appropriate, we may use it to import electricity at a lower rate to perhaps fuel an electric car.
That's the kind of thing, and it also means that you've got better access to information as to how much usage you've got at any given time. So if you think most of your devices are off and there's still a significant amount of electricity, it might be that you got stuff on standby that's pulling more electricity than you realize, that kind of thing. But it also means that you should be getting accurate bills that reflect the actual amount of usage of electricity or gas that you're using in the month that you're being billed. Now, yeah, they can actually be programmed to send out a recording of the usage every few minutes, and they do also allow for the possibility of much more flexible tariff arrangements. So you might, for example, get a text message saying for the next 3 hours there's a reduced tariff of so and so, and that's when you throw all your washing in the machine and all that kind of thing, if you want to minimize your bills. That's the kind of thing that starts to be enabled with smart meters. Now,
does it actually happen yet, Gary, or is that a thing for the future?
It's starting to happen. There's I think it's EDF's got a tariff called Flex, where it's actually already happening.
Because in the olden days, you used to, when meters were inside, you used to be able to watch the speed at which the wheel was whizzing round, didn't you? And it was pretty obvious what you were using.
Sure.
My son's got a smart meter and it displays what he's using, and it's particularly helpful because he's got electric radiators. So I think there's perhaps an age thing here as well. And how much people know.
Yeah, and I believe you can also get them to display on your phone. Yeah, if you know the code for it. Now, the first generation smart meters were a bit of a pain, really, because every supplier had their own smart meters, and if you change suppliers, which the government was encouraging people to do, whenever they whenever their contract came up for renewal, they were encouraged to go to the market, find out who's offering the best price, and then change. But the early generation of smart meters, the moment you did that, you lost the smart functions. Now, that's just very recently been sorted out in the last couple of years. So the current generation of smart meters automatically go over to your new supplier if you choose to change the supplier. And I would say that in the future, there's a fair likelihood that that there will be a further generation of smart meters that are set up to communicate with devices on your that are running in your house. So that, for example, you'll be able to get a feed of how much your washing machine is using, or it could maybe send a signal out to the washing machine saying, can you stop for 10 minutes? There's a shortage of supply just now. So that's the kind of things that are likely to be happening in the near future. Now, there's a number of different kinds of tariff for residential, small business and large business. We're all familiar with the residential tariffs, where you might have 1 or 2 different rates, and you pay a daily fee and then so much for every kilowatt hour. Now, more rates are likely to be available, more flexibility in the future, but also there will be things like on the large commercial side, a lot of tariffs have something called a KVA charge, and that's basically how much electricity, to do with how much electricity is coming down the pipe at any given time, and you get charged a fee for the maximum draw over a half-hour period. So your busiest half hour over the month, you'll get charged a KVA charge for. And they sometimes also get additional fees for damaging the waveform of the electricity, which makes transmission a little less efficient. So, it should be a nice, neat 3-phase supply that looks like the waveform on the image at the bottom of this picture. But sometimes certain loads can make these waves go a little bit square, or take chunks out of it, or can slow it down or speed it up a little, and that puts extra resistance on the wires. And so that's why big commercial users have the possibility of being charged for basically messing up the waveform. Now, we mentioned before about future tariffs. Now, they're likely to have a base that's rather similar to today, but there will be certain times when, for example, it might be very windy, there's a load of electricity on the grid, and the grid operator wants to get some of the electricity taken off the grid. So they, like I said, they would maybe send out a text message saying, next couple of hours there's a special tariff, or if you've got an electric vehicle with a smart charger, they may actually, if you've got your vehicle plugged in, they maybe ramp up your charge to full power, and then later on, when the wind dies down, they'll slow down the charge rate. And so there'd be different tariffs to recognize when electricity either needs to be taken off or put onto the grid. So you might be asked to defer usage and get paid for turning certain things off. You might get asked to use a bit more just now, and in some cases, EV owners have actually been paid to charge up their electric vehicles for short periods of time when there's too much power on the grid. Now, this adjustment of the timing of electricity use is demand side management. And in the future, it's likely that Internet of Things devices will be able, in many cases, to participate in this. And they'll be sent signals by the grid operator through the smart meter saying, can you slow down? Can you turn off for a few minutes? Can you turn on just now? And devices like the ones shown here generally are not critical as to when they operate, so long as they're not on or off for too long. So if you don't actually need a full charge as soon as possible, then there's no reason why your electric vehicle can't slow down its charging or turn it off for half an hour because the grid needs power elsewhere. Likewise, your washing machine, even your fridge can maybe stay off for an extra 10 minutes or go on 10 minutes earlier than it might otherwise. And each time anything like that happens, it means a little bit more flexibility on the grid, and it effectively acts like a virtual battery. And of course, batteries themselves can be charged up or discharged at the behest of the grid if you set them up that way. Am I going too fast for you? Any questions, anybody? Yes, like I said, smart devices can be programmed to up or down regulate depending what, there could effectively be a market on the grid. So if, for example, the price goes below a certain level, you might have programmed your car to switch on the charger if the price goes down to 8p a kilowatt hour. You might do that. Or else you might set your batteries, if you've got batteries on a solar power system, to sell power to the grid if the price goes to 20 pence a kilowatt hour. So those are the kind of things that would be that a flexible market would effectively buy balancing services from the customer.
Harry, can I ask you a question, please?
Certainly, Henrietta.
The last thing in the world we want people to do is to rush out and replace their white goods and other things. I'm familiar with the concept of the Internet of Things. Is it going to be possible to offer retrofitting of perfectly good devices so that everybody can participate in this? Otherwise, we will be offering incentives for just those who can afford it.
Well, I think it's the kind of thing that there will be a sort of natural replacement cycle. And I would expect that more and more devices would be built with Internet of Things capability. You know, so when you next come to change your washing machine, it might be in 5 years' time, you would probably have Internet of Things capability built into it. Meantime, my guess is, I don't know, but my guess is that some devices might allow participation by means of a device that you plug in between your socket and your plug, for example.
It'd be good for hot water, wouldn't it?
Yeah. But that, I mean, with your hot water, you need to have an electrician install a device. But things like your washing machine, you may be able to, program it to interrupt its cycle for 10 minutes based on a device that's plugged into the wall. But I'm not certain of that. I have reservations about doing it with fridges, though, because the device plugged into the wall wouldn't know what temperature your fridge is at, and you don't want it going out of the allowable range. We might get away with it with a freezer, because that's not going to go out of an acceptable range in a 20-minute period or whatever. So basically, on things like electric vehicle chargers, you'd have a market. There'd be, the grid operator would offer different prices. They'd offer certain prices at certain times, and you can basically program your charger to bid for it at that time. And so basically when the price drops to what you want to pay, your EV charges up. And obviously, if you'd want a certain amount of charge by morning regardless, so you'd maybe set a fallback position if you don't get any special offers that night. Now, Internet of Things, that's basic. Well, I think we've pretty much covered what it is, but basically it's devices that are set up so that they share information over the internet and can potentially be controlled over the internet. Things like a lot of doorbells now are set up that way so that they'll interact with your phone, for example, send a message via the internet to your phone. Things like your heating with the Hive controller already is Internet of Things controlled, because you can go on your mobile phone and turn your heating on remotely. And more devices will be set up that way. Obviously, there's certain devices that you won't want turning off. I mean, you want your lights to be on when you switch them on. You want your, you don't want your television or your radio cutting out because there's a shortage of electricity unless it's really desperate. But things like the devices I've been talking about are able to be off for a little while to help out the grid. Now, there is a fundamental difference between electricity and water. water, you've always got water stored and it's ready in reservoirs. So when you turn the tap on, you draw it off the reservoir, and you know, so long as you haven't got everybody turning all their taps on at the same time, you should always have a water supply. But electricity, conventionally, it's always been done that like fossil fuel power stations or hydropower stations ramp up and down to make the balance, and it's always used at the same time it's produced. Now, because there's a growing amount of renewable energy on the grid, that's getting harder and harder to do based on purely ramping the fossil fuel power stations and the hydro. And it's starting to become much more important that other methods like demand side management and possibly some storage on the grid in the form of batteries comes in to help with the balancing task. And it's important that there is a balance, because otherwise you get all your clocks running at the wrong time, you get voltage dips or spikes, you can end up with power cuts, brownouts, all sorts of issues with the supply if it's not balanced. Now, are you still with me? Am I losing people on this?
No, it's all good. All good.
Right. Yeah. Okay.
Yeah, all good.
Yeah. So I've actually just talked about some of this on the previous slide, but never mind. Like I said, traditionally, grid balancing was done by means of spinning reserve generators running on part load. So you ramp them up and down when needed, or in some cases you'd have a generator that's just spinning with no load on it. So basically it's burning a certain amount of fuel and not generating any electricity at all. But the moment the grid frequency starts to dip, it cuts in and starts putting power onto the grid. Now, there were several tiers of reserve, some that had to be instant, like the spinning reserve, some that could come online after a few minutes, like small gas turbines, for example, take a relatively short time to ramp up, and others that can be brought online at a few hours notice. So that if, for example, it's a very cold day and there's going to be a big peak in demand on the evening, you might, 11 in the morning, start ramping up a coal-fired power station to have steam ready to generate at capacity for that projected evening peak. So like I say, that was always in the past done by fossil fuel or hydro. Now, so because of the increase in renewables, and because we're wanting as far as possible to keep the likes of coal off the grid because it's the dirtiest fuel, demand side management starts to become very useful, because it provides a lot of that spinning reserve. And if you can, for example, defer the charging of your electric car, then it's far less likely that that if 1 million people do that or whatever, that it's far less likely that some of the power stations that are low on the merit order, like the coal stations, will ever need to be cut in. Yeah. And of course, batteries, which are becoming more common with domestic solar and with commercial solar on rooftops, and also utility scale solar power stations can also participate in this balancing market and help to keep the lights on when without having to ramp up the fossil fuel power stations. Now, like I said before, the current arrangements for demand side management are mostly aimed at big users. So, there'll be, things like, you might have a foundry that melts metal to cast metal items, something like that. They'll maybe ask them to choose to do that at night time rather than in the daytime when there's a peak demand. Big centralized air conditioning systems in shopping centers and such like, same thing. And also there are certain sites like hospitals and shopping centers which might have their own generators. Now, being relatively small generators, they can ramp up pretty quickly. And so the grid might actually call for them to be switched on for a little while. With the Internet of Things and low-cost trading setups, powered by software, it becomes more and more possible to have a market that all the smaller devices and sort of things you'd have at home can play in and help to manage the grid. Obviously, the likes of televisions and lights, you want them under your control. Laundry, refrigeration, heat pumps, EV chargers, most of the time can be switched on or off for a little while at least without disrupting their function. Now, one of the concerns that people might have over this is the possibility that they may lose control, that they'll want, for example, to charge up their car for the morning, or they may be going out in the evening. They've used up most of the battery in the daytime, but they want to go off to visit their relatives in Cornwall, leaving at 10 o'clock tonight. Well, in that instance, you're going to want to charge at peak hours, which the grid would prefer you don't, and will give you an incentive not to, but you will be able to override it, and you'll be able to say, no, I really want to charge it tonight. I want a full charge by 10 o'clock tonight, and so you'll maybe pay more for your electricity just for that one occasion when you want to charge at peak hours. So that, one of the things I've talked about is refrigeration equipment. Now, obviously, it's got to operate within an acceptable temperature range, which is usually 2 to 5 centigrade for a refrigerator. But what tends to happen is, you might be, your refrigerator might be programmed to cut in at 3 and cut in at 4 and cut out at 2.5. But if there's too much power on the grid, it can wait another 10 minutes and let the temperature go down to 2. It can maybe let it go all the way up to 5 on that particular occasion if there's a shortage of power. So that way you just borrow 10 minutes of its usage, and then when there's more power on the grid, you drop the temperature back down again. It doesn't sound like a lot, but one of my colleagues when I was at university did a study of this and reckoned that if every fridge and freezer was programmed that way, there'd be effectively the equivalent of 2 gigawatts of spinning reserve, which is the equivalent of a couple of nuclear power stations. So that's quite a bit of flexibility, albeit with any particular fridge only maybe staying on for an extra 10 minutes or staying off 10 minutes longer. Now, on the electric vehicle chargers, just recently they changed the requirements for electric vehicle chargers, and every charger that's now fitted needs to be capable of smart charging. meaning that it's capable of interacting with the grid operator, so that if you allow it to, it will charge your car when it best suits the grid. So if you're parking all night, it doesn't really matter to you whether it charges at 8 in the evening or 4 in the morning. It'll go for 4 in the morning because not many people are using a lot of electricity then. And then in the future, there'll be a further step with two-way chargers on electric vehicles. So they can effectively become a grid-connected battery, which is capable of supplying the grid, so that you might allow a certain amount of kilowatt hours to be delivered from your electric vehicle into the grid at peak hours, and then get them back cheaper later in the night. And the same applies with, for example, the battery that you might install with a solar power system. Or it might just be set up so that it's capable of supplying the building, but not exporting to the grid. That's a sort of intermediate kind of stage. So that would be particularly useful in a power cut. So you'd use your EV charger and your electric vehicle to keep everything running in your house while the mains power's down.
So Gary, what's your sort of time scale on this happening? Is it required now as we move hopefully towards more green supply? And is it tenable, feasible, anything else once we reduce our reliance on gas? Of course, is not yet here, is it?
Yeah, well, all these things are in the very early stages of ramp up, I would say. They're technically feasible now, but not in widespread use. And it's my expectation that over time, probably over the next 10 years, more and more will come in. And in 10 years' time, it might be perfectly normal for anybody fitting an electric vehicle charger to have a two-way charger rather than just drawing off the grid.
Gary,
how efficient is the process of loading your car battery from the grid and then back feeding from your battery into the grid? There are obviously going to be losses in both directions.
Yes.
Have you any idea what those losses might be?
I would expect that the cycle efficiency, so long as you're not drawing at high power, would be around 90%. So you're losing about 10%.
Gary, can I just, I don't know if this is hearsay or whether it's true, but I'm sure someone told me that the Nissan Leaf currently can import electricity from the grid at a relatively low price at night and export the electricity into the house or the grid at a higher price to save a lower price to save you money.
Yes, it's the first mainstream electric vehicle that's designed for connection to a two-way charger. I think it'll increasingly become normal as new models are introduced for that feature to be offered. I'm not quite sure which other models have it available. There was a Nissan van that I believe has the same battery as the Nissan Leaf that can do the same thing. And I believe a number of other manufacturers are looking to do it in the near future.
So does this mean, Gary, that down the line, we don't need to build so many facilities? We don't need so many wind farms. Thing, is it, presumably?
Yeah, well, the idea is that you'll be able to more easily balance the supply and the demand, and as more and more electric vehicles, for example, come online and have are connected to two-way chargers, you'll have the capability, for example, of meeting the the evening peak, without having to bring in less efficient generators, for example. So so you'll have an increasing proportion of electricity either produced by renewables or by the very most efficient fossil generators, and eventually, hopefully, we'll get to the point where we won't need to have fossil fuel on the grid at all. But it will take a while, and we will need cheaper storage technologies than electric batteries. For example, there's some that are based on molten metals or heating sand to high temperatures to create steam. It's not so, melting salt. It's not quite so efficient as charging a battery and discharging it, but once you get to the point where you've got a large surplus of offshore wind, for example, if you lose a certain percentage in order to be able to store it cheaply, then that's a trade-off. Basically, you work out the most cost-effective way of operating the system as a whole, and it might be cheaper to heat up sand to 800 centigrade to make steam later, rather than paying much more expensive batteries.
Yeah, thanks, I understand.
So anyone else like to ask anything?
I have a question.
Certainly, Tony.
You've mentioned once or twice this Internet of Things.
Yeah.
On the other hand, one does hear rather disturbing stories about how much hackers can use this to create havoc with your either finances or something else equally disturbing. Do you envisage that these devices will be more foolproof than perhaps they are today?
Well, there will need to be security measures put in place, and one of the things that people, the sort of thing that sometimes happens now, for example, is might have a baby monitor or something like that, and neighbours end up hearing the conversation, or you might have a baby monitor with camera, and then the neighbours can see everything going on in your house if you haven't set a suitable password, if you've left a default password on, for example. So it may be that we'll need to take a certain amount of responsibility ourselves, but there should also be measures that the manufacturers install on anything that's of any sensitivity at all, to so that you pair it up, for example, with your phone and not anybody else's.
Oh, right, thank you. Encouraging.
I'll just add one quick thing, Gary,
Certainly, John.
which you haven't mentioned, but I think exists, and that is if you've got a big dam, hydro dam that's actually producing electricity. They have got to the stage now where they use the electricity in the middle of the night to pump water back into the reservoir, so they've got a decent head of water for the next day.
Yes, there's two such power stations in the UK, De Norwig in Wales, and there's another one in Scotland. I can't remember the exact figures, but I think the Norwig one's capable of either taking 1.5 gigawatts off the grid or generating 1.5 gigawatts, depending what's needed at the time.
I thought that's always how they worked. I thought that was the basic principle of them.
Well, that's how pumped hydro works. But,
yeah.
But of course, with an ordinary hydro reservoir, you've also got the option of turning it off when you don't need it. So in the daytime, when the sun's shining in the middle of summer and there's loads of solar power, you don't need the hydropower maybe in the daytime. And so you keep it in the reservoir until the evening when the sun goes down. So it's a bit like the smart charger and the two-way charger, with the pumped hydro being an analog for the two-way charger, and the regular hydro just the equivalent of a smart charger.
Are there any more questions? Have you got anything to add, Nick?
Well, it's been a very interesting presentation. I suppose I'm interested in how to try and turn on local communities, to inform local communities and sort of engage local communities on this. And there are sort of a number of steps that you can take along the DSR journey, starting with a smart meter, to fitting solar panels, to getting a household battery, to getting an electric car with bi-directional. But there needs to be a sort of a growing awareness about the need and also the opportunity, because as John mentioned, he's trying to set up to make this work for him financially. So, but it's almost like there's almost like a moral imperative for us all to learn about this stuff.
Well, I mean, at the moment, I believe EDF is doing trials in certain areas of two-way chargers, where, I mean, they are one of the difficulties with them is they are currently not in mass production, and so they're consequently quite expensive. You know, upwards of 2,000 each, and so there's a little bit of a balance between how much people are prepared to pay for it, and how and the potential usefulness of it. I mean, I think over time, possibly another 18 months or 2 years, they'll come down, so they're maybe just a bit more than the one-way charger, but we're not there yet.
Has anybody heard if the rechargeable car that was to be put in the Liston Road car park by Bucks County is actually there and being recharged and available for hire?
I do know that it was due to be at the very end of August.
That's my understanding.
And it's been delayed until sometime in September, middle of September-ish, was what I heard from the town council.
Okay, well, that's something we can look forward to seeing.
Yes.
Giving a run out.
Gary, how are we going to persuade politicians, especially my local one, I'm not quite sure if he's also the Marlow MP, that this change is both needed and won't ruin our lives?
I would say, I mean, if you're talking about Steve Baker, that if the market does it, and I think the market will send signals that you begin to make it more and more attractive over time. I don't think you'll have a problem if the market pushes it to happen. It's already starting to happen quite a lot with electric vehicles. We're sort of doubling or tripling the proportion of electric vehicles going onto the road each year now. I mean, there's concern from some people that about the policy of not allowing internal combustion engine powered cars on the to go onto the roads after 2030. But I think in reality, come 2025 or thereabouts, there'll be such clear advantages in going for electric that most people won't want to have a fossil fuel powered car anyway, or won't want to be buying a new one, put it that way. Because once the price of an electric car gets down the same as a petrol car, and you can charge it at home, and once there's enough infrastructure for charging when you're away, then it's less maintenance, far less fuel cost, certain tax advantages as well. Why would you buy a fossil fuel powered car?
But will the Chancellor of the Exchequer then start bringing road pricing to offset the loss of tax that he's currently raising on fossil?
Well, there will need to be some mechanisms for, for providing revenue, and of course even electric vehicles do have a significant environmental impact,
right? Because
before your car even sees the road, it's used probably the equivalent of a couple of years worth of its energy consumption just in the manufacture and in the mining of the materials used to make it.
One of the things that also I haven't got any clarification on at all is the mandated use of heat pumps in the foreseeable future to replace gas boilers. Now, if all my neighbours were to put heat pumps in Rookery Court, we'd have 40 heat pumps turning on at the same time. And I've no idea whether the mains power infrastructure is capable of handling that, plus all the cars that are being charged up in the evening as well.
Well,
there's clearly going to be a very different demand on the grid.
Yes.
Caused by a very fundamental changes to the items we use that consume electricity. With the number.
Yes, well, with these heat pump arrangements where you've got like heating with a sort of radiator or underfloor based water-based system, there will be a fairly substantial buffer tank, generally speaking, and that should, in most occasions, make it possible to, to turn off or turn down your heat pump during the peak hours.
I haven't found where I'd put my buffer tank in my house. Probably means giving up a room, by the sound of it.
Well, there are actually some systems where the tank and the heat pump are in the same enclosure outside.
Okay.
And where you've just got electrical and water connections from inside to the heat pump. So that is an option.
I haven't seen that design.
Yeah, obviously it needs to be better insulated because it's in a colder place than your rooms. But yes, it is available.
Right, I think we've probably got time for one more question. We try to limit these to an hour, and we're approaching 8 o'clock. Has anybody got one last question for Gary? Sounds like a no. If that's the case,
well, I just wondered if the government needs to be doing something to encourage this, really, as part of the green energy push. Could they encourage this, because it needs to speed up, doesn't it, quite considerably, in order to not have to build more power stations, not even have to build more wind farms, really. So what would be the sort of edge that government could give this to hurry it along?
I think one of the things that government can do rather better than it's done in the past is have some kind of consistent and predictable policies. For example, the feed-in tariff, they brought it in, and then a couple of years later they made a massive drop all in one go on the feed-in tariff rate, and then a few years later they cut it out altogether with little warning. If it were a much smoother process where any incentives are more or less predictable and help to cover the additional costs of these kind of things, as opposed to and sort of ramp down as the market price of, for example, heat pumps reduces, then that would be very useful. Things like the policy they brought in for, you know, these, I forget what they call it, the green grants, and then 6 months later they cancel it. That's no use to anybody, because the, you know, the suppliers don't get to ramp up. They don't get to train the people to do it. Those that do, you know, they spent all this money on training, and then 6 months later they haven't got any business.
They're still offering grants to homeowners to switch to condensing boilers, gas boilers. So the message there is rather a mixed one, isn't it?
Yes, it is. I mean, I think, yeah, I think probably one of the things that could be done is, I mean, heat pumps aren't yet as efficient as they technically could be with a little bit more development work. And so, I mean, I think one of the things they might do is put some money into research and development to actually make better heat pumps that, you know, that can be made more cheaply, that run more efficiently, that can maybe, you know, run, you know, can maybe pump, you know, put out hot water at a slightly higher temperature without losing efficiency as a result. And that would help the take up, because then it becomes a more doable thing without, you know, and currently if you're going to put a heat pump in, you possibly end up having to change all your pipework and all your radiators to, you know, to have larger diameter pipes so that the water flows more freely, and to have bigger radiators so that they can run at 40 degrees centigrade instead of maybe 60 that they got the gas boiler running at.
Yeah. John, can I, it's a slight segue onto a slightly different subject, but it's still sort of DSR. Just interested, I learnt about the project down near Well End for quite a large 7 megawatt battery facility that's supposed to be providing, well, demand side response, frequency balancing services.
Yeah.
With the grid.
Yeah.
Has Meg taken any interest in this? Sorry, Gary, do say what you were going to say.
Well, obviously it's useful to have some of these facilities in the right places. I mean, there might, for example, be a load of like stacking advantages, for example, you know, because there'll be a load of different revenue streams that a battery could potentially use. For example, you might choose to install the battery at a hospital, so it becomes backup for the hospital. So, you know, it gets a certain amount of revenue for being a, like, you know, emergency backup. It gets a certain amount of revenue for being able to respond to the grid and help the, you know, grid balance. Frequency response, it might be brought in to cope with the local voltage, because frequency is like a national thing, but you can get fluctuations in the local voltage if all of a sudden a local user pulls a lot of power, for example. And then also there are certain situations where you'd maybe have a choice between like putting in new, more powerful cables to a town, for example, or installing a battery system to cover the peaks at the local transformer. And so you may be able to defer investment in the grid.
Okay. Right. Just before we wind up, can I just give you a couple of announcements? In early November, we're having a general talk, not an Ask the Experts, but a general talk and discussion on COP26, which should be very interesting. In December, we're having an Ask the Experts event, which will be about robots. In this specific case, robots that actually go under the floor and spray insulation under the floor. There may be another robot company also giving information about robots, but that's in the future. Anybody who's not a member of MEG at the moment, can I ask them to consider joining? All they have to do is go on the website and you can join. Having said that, can I first of all thank Gary for an excellent talk, really informative, very useful, lots of good stuff there. And can I thank everybody else for coming along? You will be able to see this presentation on our website in probably a week's time, if you'd like to see it again. Thank you, everybody, and good night.
Thank you.
Thank you.
Well done. Thank you very much.
Thanks.
Bye.